Hello students, welcome to Sri Jayendra's Ring Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 4 of a unit Magnetism and Matter. Today we are going to discuss about the Earth's magnetism. So let's begin with the Earth's magnetism. This is an image is there and that this represents the Earth. As you can see that the Earth has at its center a dense liquid core of about half of the radius of the Earth with a solid inner core, and this contains a circulating ions of iron and nickel in highly conducting liquid region of Earth's core. And that's why we have assumed that this current loop may producing Earth's magnetism. In reality, we don't know why the Earth contains a very huge magnet. So we have a certain theories, and within those many theories, one of the theories is that at the center of the Earth, uh, high concentration of iron and nickel highly conducting liquid region could be there, and due to this currents, Earth can behave as a magnet. I hope this is clear. So we can say that the Earth itself has a huge magnetic field, as if we can consider that it is having a huge bar magnet embedded at its center. Thus, in reality, the north magnetic pole behaves like the south pole of a bar magnet inside the Earth, and vice versa. Because when we are considering this magnet, then this north pole can point out towards the geographical south, and south pole is pointing out towards the north pole of the geometrically north pole. I hope this is clear. Is it so we can consider that it is having a magnet, and that magnet is having a magnetism. And when we say that, let's suppose this is north, this is east, this is west, this is south, then there is a certain tilted angle would be there. This could be said as a magnetic north, this can be said as the magnetic south. And these are the magnetic field lines that I have represented over here. Yes, this magnetic field lines are the field lines that has been developed by the bar magnet that we assume at the center. Yes, so when it is at north point, so that's why we understood that, or we assume that this must be the south pole and this must be the north pole of a bar magnet. I hope this is clear. Now is it clear? Now let's discuss the magnetic elements it through which we are going to study the complete magnetism. To describe the magnetic field of the earth at any place, the three quantities or elements are required. One is the magnetic declination, second it's a magnetic inclination, and the third is the horizontal component BH. So let's begin with the magnetic declination. We can say that magnetic declination is the angle between magnetic meridian and geographic meridian. Now, the question is, what is magnetic meridian and what is geographic meridian? So what we are assuming is that, let's suppose understood that this is the earth, and if this is earth, this is north, this is east, this is west, this is south. Yes, so this is geometrical north, this is geometrical south, and over here certain angle theta, something like this could be the magnetic north, this could be the magnetic south. So if I pass one of the plane from geometrical north south, something like this, if I pass one of the plane through geometrical north south, this plane could be called as the geometrical meridian. A same way if I pass one of the plane from the magnetic north south, something like this plane can be said as the magnetic meridian. So these two are the imaginary planes. These two are the imaginary planes which we have derived, or which we can say we can represent for our convention, because the whole magnetism or whole Earth's magnetism has been defined with reference to a magnetic meridian. So we have defined these three planes so that it would be much easier to understand the people that what and at which place we are talking about. I hope this is clear. So magnetic declination, it is the angle between magnetic meridian and geographic meridian. This is the angle. It's a magnetic declination. Yes, it is an angle between geometrical meridian, or we can say it's a geographical meridian and magnetic meridian. Does it clear? Does it? Great. We can say that it is the small angle. It is the small angle between magnetic axis and geographical axis at a place that defined as the magnetic declination. This is, as we have discussed in the previous slide, this is the true north pole and this is the magnetic north pole. The angle between these two, the angle between these two represents the angle of declination. In a 3D view, it is something like this, that this plane is the geographical meridian, and this plane was the magnetic meridian, and the angle between this two can be represented as angle or magnetic declination. Now now let's have a question. It says that the small angle between magnetic axis and geographic axis at a place, the small angle between magnetic axis and geographic axis at a place is defined as the magnetic declination. I hope this is clear. Next, it says that the magnetic field is now thought to arise due to electric currents produced by convective motions of the metallic fluids in our outer core of the earth, and this effect is known as the dynamo effect. What we need to do is, and what we need to understand is, that this is completely theoretical unit, complete theory. What we need to do is, we need to target this unit first. Subjective kind of questions can be asked from this unit and at a competitive examinations, and even that has been asked. So you need to learn this, you need to remember is, you don't have any option. Second, this unit is very useful to cover good numbers in the board examinations. So this is completely descriptive units, where theories will be there, and you need to remember that you don't have any other option, we don't have any other option. I hope this is clear. Great. Now let's focus on the magnetic inclination. What is it? So it could be said as the magnetic dip or magnetic inclination. It is the angle between the direction of total intensity of earth's field with the horizontal line. Let's say this is horizontal line in the magnetic meridian. So let's suppose this is the magnetic meridian and this is the horizontal line of the magnetic meridian, and let's suppose magnetic field enters this horizontal line by certain angle. That angle can be represented as delta. Yes. So this is the magnetic dip, or it's an inclination. If you look at this, it is the horizontal, this is the vertical line, and if you observe this suspended compass, this is the north pole, this is the south pole, and this is from north to south. The From north to south, we are having the angle of delta. This is the BE. It's an magnetism of earth. Yes. So this could be represented as delta, and when I say at poles, when we consider this at poles, the at poles angle of dip, it is the 90 degree, and at the equator angle of dip is 0 degree. Yes. Let's have a few more information about the dip. The dip at a place can be determined by an apparatus known as the deep circle. So we are using deep circle to measure it, and the needle rotates freely in the vertical plane of the scale. The pointed ends move over the graduations on the scale, which are marked from 0000 degree in the horizontal to the 90 degree in the vertical direct. Yes, it is going to be deflected from 0 0, as you can see this from here, 0 0 to 90 degree. Is it clear? Is it great? So the declination, we understood that declination is greater at higher altitudes and the declination is smaller near the equator. The declination in India is very small, it being approximately 0 degree and 41 minutes east at Delhi and 0 degree 58 minutes west at Mumbai. So, so we can say that at both these places the magnetic needle shows the true north quite accurately, because there is only a difference of 41 degree or there is only a difference of 58 degree. There are certain places in the world where this declination is very high, and once the declination is very high you need to correct it to reach to land on the right location. Yes, so this is much required, and we are having very lesser value that is useful for us. So there is one more quantity of interest. If a magnetic needle is perfectly balanced about a horizontal axis so that it can swing in a plane of the magnetic meridian, then the needle would make an angle with the horizontal, and this angle is known as the angle of deep. Thus deep is the angle though the total magnetic field, we could call it as an BE of the earth, makes with the surface of the earth. It is this angle, something like this. Yes, this is BE and this is the angle D. It shows that the magnetic meridian placed at a point P on the surface of the earth. Let's suppose this is the point P, and the plane is a section through the earth. Yes, so if I want to find out the total magnetic field at P, can be resolved into two components. I can divide it into two components. One of them is the BH, another one is the BV. BH is said as the horizontal component and BV it's said as the vertical component, and the angle that B makes with BH is the angle of dip. Here I have represented it by I. Even it can be represented by delta. Yes, this can be shown like this. This may be probably the easier diagram to understand and to visualize. This is BE. So if this is delta, this could be written as BH because this is the horizontal component, and that could be written as BH is equals to BE cos delta. This is BH is equals to BE cos delta, and this is BV. It's a vertical component of Earth's magnetic field. That could be written as BE sin delta. Does it clear? Does it? Great. In most of the northern hemisphere, the north pole of the deep needle tilts downwards. Likewise, in most of the southern hemisphere, the south pole of the deep needle tilts downwards. And to describe the magnetic field of the earth at a point on its surface, we need to specify three quantities: the declination, angle of deep, and inclination I, and the horizontal component of earth's magnetic field. Yes, so what we are having is this are known as the elements of earth's magnetic field, and we are having this relation which is BV is equals to BE sin delta, and BH thus should be is equals to BE cos delta. This is relation number 1, this is relation number 2. If I take a ratio, it would be a 10I, or certain authors write there as a 10 delta. It's an angle of deep, so 10 delta or 10I. Shall I rewrite it this? It's a 10 of delta. Yes, this 10 delta should be written as BV by BH. This is important relation. I must remember this 10 delta would be equals to BV by BH. Now let's discuss magnetic inclination or magnetic dip. It is the angle which the direction of total strength of Earth's magnetic field makes with the horizontal line that we have already discussed, and angle angle of Earth's magnetism's horizontal line and horizontal plane and the axis of freely suspended magnetic needle is angle of dip or inclination. Is it clear? Is it? Are you sure? Are you sure? Now, now let's suppose understood that certain logical things that what happens if we take our compass to the magnetic pole. So what we understood is at the poles the magnetic field lines are converging or diverging vertically, so that as they are converging or diverging vertically, so the horizontal components is negligible. And and we understood that if the needle is only capable of moving in a horizontal plane, it can point along any direction, rendering it useless as a direction finder, because it is not going to be used as a direction finder. It can be pointed out at any direction. Now, what one needs in such a case is a deep needle, which is a compass, pivoted to move in a vertical plane only, that contains the magnetic field of the earth. And that's why the needle of the compass then shows the angle with which the magnetic field makes with the vertical. And at the magnetic poles such a needle will point straight down. I hope this is clear. Is it is it clear? Great. Now blank is the angle that the total magnetic field of the earth makes with the surface of the earth. Yes, it is. Deep is the angle that the total magnetic field of the earth makes with the surface of the earth. Second, at poles the angle of deep is 90 degree. I hope this is clear. Is it clear? Is it is it clear? Are you sure? Are you? Great. So now ready for the questions? Are you ready for the questions? Are you? So have you written the relations? We have 10 delta is equals to bv by bh and all that. Have you written it? No? Okay, not an issue. Let's begin with the numericals, and if required I will give you the time to write it down. So it says that the vertical component, says vertical component of Earth's magnetic field at a place is root 3 times root 3 times magnitude of horizontal component. Find out value of angle of deep. So angle of deep is required. And what does it say? It says that vertical component, that is bv, of a earth's magnetic field at a point is root 3 times of the horizontal component. So this is bv is equals to root 3 vh, and this could be written as bv by bh, that should be equals to root 3. When I do this thing, it's a 10 delta, which is equals to bv by bh, and this bv by bh is the root of 3. when i say root of 3 when I say root of 3, this theta, or I should say angle delta, sorry, this angle will be equals to 60 degree. I hope this is clear. Is it is it now let's suppose in this question, if magnitude of if magnitude of magnetic field by earth is required, what could be done? What is to be done? It says that if magnitude of magnetic field by earth is required, so what I'm having is that bv by bh, that is equals to 10 delta, and that is equals to root of 3. So what we are used to is bv is equals to bh cos delta. bv is equals to bh, sorry, sine delta. One second. Yes, bv is equals to bh sine delta, and bh, it's a be. This should be written as be. Yes, bh is equals to be sine delta, and bh is equals to be cos delta, and bv is equals to be sine delta. Let's suppose this is relation number 1, this is relation number 2. If I add this, but before we are adding it, we are going to square it and then add it. So if it is the situation, this could be written as bv square plus bh square. That should be is equals to, sine square delta plus cos square delta, and this is equals to 1. So this is just the bv square plus bh square is equals to 1. I hope this is clear. Is it clear? Are you sure? Now one more thing is that this, how could I find it out? This is as a be square. This be could be written as under root of bv square plus bh square. Yes, we have bv given. Yes, it says that this is root 3 times of magnitude of, so put up the value such as bh is equals to root 3 times of be, and put up the value and get the answer. Does it clear? Does it? Are you sure? Great. Now let's discuss one of the very very important and very logical application of earth's magnetism. Let's have a look very 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 carefully. It says that, let's suppose that the true value of of angle of deep at certain place is delta. The true value of angle of deep at certain place is delta. If the vertical plane, carrying a magnetic needle, the vertical plane carrying a if the vertical plane carrying a magnetic needle is being rotated from let's say theta with magnetic meridian, what I required find out apparent angle of deep. Yes, so go through the data once. You might have get an idea that what I required. If not, I'm there to help you guys. Let's have a look. It says that the true value of angle of deep at a certain place is delta. But now if the vertical plane carrying a magnetic needle is being rotated from theta, yes, so rotated for angle theta and with magnetic meridian, now find out the apparent angle of deep. So first attempt should be made to check the direction, or to have a rough sketch. That, let's suppose this is the magnetic meridian, and when I say this is the magnetic meridian, the thing is I have rotated it I have rotated it from something like this, and this angle is theta, which is equals to 30 degree. Now what I understood is this was BV, or this is BE, sorry. So this is BV dash and this is BV because the vertical plane remains the same, and this BH dash, that should be is equals to BE cos delta. Got it? Does it clear? Does it? This is BH dash, sorry, I made a mistake, it's a BH dash. This was the BH. So this is BH dash, which should be equals to BH cos theta. Now when I write 10 delta, it is just the BV by BH. This is the true angle of dip. Now apparent angle of dip, when it has been rotated by certain angle theta, then I can write this, it's a 10 delta dash should be equals to BV dash divided by BH dash. And when I write BV dash by BH dash, it would be a BV, because BV dash and BV equals to same, because we have not changed anyhow vertical plane, we have not disturbed it, we have changed only the plane of the paper, and we have rotated it from angle theta. BH dash could be written as BH cos theta. Yes, so this could be written as this BV by BH. What is it? This BV by BH. Yes, it's a 10 delta. So 10 apparent angle of deep should be equals to 10 delta divide by cos of theta. Yes, this is the relation that you must remember. It's a 10 delta dash is equals to 10 delta plus cos theta. This will help us. Yes, please believe me, this will help us. Yes, so will you be ready with one of the question? Will you? Yes. So please have a note this, that 10 delta dash, while I say delta dash, it is the apparent angle of dip. While I write 10 delta, it is the actual angle of dip, and theta, it is the angle with which it has been rotated. So this 10 delta dash is equals to 10 delta divided by cos theta. So now the question says that the true value of dip, the true value of deep at a place is 60 degree. Now the vertical plane carries rotated by 60 degree from magnetic meridian. So now you need to calculate apparent angle of dip. So what all data has given, that is, first find it out. It says that true value of dip, that is 10 delta, is given as a 60 degree. Now the vertical plane that carries a needle that rotated by an 60 degree, that means this theta is equals to 60 degree. What I need to find out, apparent angle of dip. So that could be written as 10 delta A, that should be equals to 10 delta divided by cos theta. So this this is 1060 degree divided by cos 60 degree. Yes, so 1060, what is it? What does it? Yes, very good, it's a root 3 divide by cos 60, it's a 1 by 2. So this is equals to 2 into root 3. This is 10 delta. I hope this is clear. Is it clear? Is it? So Please do remember this thing, that apparent angle of dip will be equals to, the apparent angle of dip will be equals to actual dip, which we can denote by a tan delta divided by cos theta. So does it clear? Does it? Any any doubts up till now? Is there anything? Is there anything? So now will you be ready for one very good application of Earth's magnetism? Will you be? Yes. It's a little typical question. Yes, it's a little typical question. So please have a focus on this and look at this very carefully. So let's look at the question first and then we will discuss how to get it done. It says that the values of apparent angles of dip, the values of apparent angles of dip at two places measured in two mutually perpendicular planes. That it says that the value of apparent angles of dip at two places measured in two mutually perpendicular planes determine determine the true angle of dip at that place. You need to determine the true value of angle of dip at that place. So how will you do it? First, go through the data. It says the value of apparent angle of dip at two places measured in two mutually perpendicular planes. They are mutually perpendicular. Okay, great. Now you need to find out the true angle of dip. So let's suppose this is the actual magnetic meridian. Let's write it as an mm. It's a magnetic meridian. Now this is one of the plane that has been rotated by certain angle theta. This is one of the plane that has been rotated by certain angle theta, and let me make one more plane. This is the third plane. Yes, and according to the data, this and this should be perpendicular to each other. One more thing, if this is mentioned as theta, this must be mentioned over 10 minus theta. Is it clear? Is it clear? So now what I understood is that this is the actual magnetic meridian, but if I replace this magnetic meridian by a certain plane that is not parallel to it but that has been rotated, what I am having is the apparent angle of dip. And when I say apparent, let's have a look, that we can understood that this, the 10 apparent is equals to 10 delta, that is the 10 actual divided by cos theta. This is apparent angle of dip, this is the actual angle of dip, and this is the theta angle with which it has been rotated. So if I see this, the first is rotated by theta and another is rotated by 90 minus theta. Let's write it that 10 phi 1, it is the apparent angle of dip for the first plane. That would be equals to 10 delta divided by cos theta. Let's write it down. It's a 10 phi 2, which could be written as 10 delta divided by, now this will become cos of 90 minus theta. And when I say cos of 90 minus theta, that should be written as 10 delta divided by sine theta. I hope this is clear. So let's write down this as a relation number 1, this as a relation number 2. So this could be written as cos theta, that would be equals to 10 delta divided by 10 phi 1, and sine theta could be written as, this is equals to 10 delta divided by 10 phi 2. Yes, so this is, let's say, relation number 3, relation number 4. Now let's square and add this relation number 3 and 4. It's a sine square theta plus cos square theta. That should be is equals to 10 square delta divided by 10 square phi 1 plus 10 square delta divide by 10 square phi 2. So sin square theta plus cos square theta, it is 1. 1 is equals to 10 square delta divided by 10 square phi 1 plus 10 square delta divided by 10 square phi 2. So this could be represented as 1 by 10 square delta, that is equals to 1 by 10 square phi 1 plus 1 by 10 square phi 2. So 1 by 10, it's a cot. Yes, so this is cot square delta. This is the true angle of dip at that location. That could be, it's a cot square delta 1. This is the apparent angle of dip for the first plane, plus cot square delta 2. This is the apparent angle of dip for the second place. And these two planes are mutually perpendicular to each other. This is the relation we are looking for. Yes, I hope this is clear. Is it clear? Is it is it clear? Great. Always remember this because this is one of the favorite questions of the earth's magnetism point of view. Yes, people love it and that's why they ask it like anything. I hope you understand it. So please remember this relation, that cos square delta is equals to cot square delta 1 plus cot square delta 2. Even different formats of this has been asked in various test series. If I look at this various test series, the various forms are there which are something like this. Let's look at this cot square delta is equals to cot square delta 1 plus cot square delta 2. When they form four options, they just arrange it something like this. It's a cos square delta divide by sine square delta. That should be that should be is equals to cos square delta 1 divide by sine square delta 1 plus cos square delta 2 divide by sine square delta 2. Yes, this could be there. Now one more relations could be there, which could be, we know that tan delta is equals to bv by bh. So from this we have a cot delta that could be written as bh by bv. Yes, so it could be represented as bh by bv whole square. This is the bv by bv, bh by bv of actual. That should be is equals to bh by bv square of apparent first plane plus bh by bv of apparent of second plane square. Does it clear? Does it? Are you sure? Are you sure? Yes, great. So different kind of questions could be asked, different types of questions could be asked, and they could have a different category of options. Yes, but you must remember this master formula. Yes, and from this any of the form can be derived. I hope this is clear. Is it clear? Is it? So will you be ready to have one of the questions based on this? Let's have a look. It says that the values of apparent angles of deep at two mutually perpendicular planes are are 30 degree and 45 degree. Find out, find out true angle of deep. Find out true angle of deep at that place. I hope this is clear. Is it clear? So let's have the formula and get the answer. It says that cot square true angle of dip, that should be is equals to cot square first apparent of dip plus cot square second apparent of dip. Yes, so this is cot square 30 degree plus cot square 45 degree. Yes, it's a cot square 30 degree plus cot square 45 degree. So cot 30, it's a root 3, it's a square, it's a 3, plus cot 45, it's a 1, it's a square, it would be a 1. So this is equals to 4. So cot square delta is equals to 4, and from this I am having that cot delta is equals to 2, or delta is equals to cot inverse of 2. So does it clear? Does it? Now will you be able to solve this kind of questions? Will you be? Are you sure? Are you sure? Ready to do one more question? Interested in one more question? Are you? Can we do it? Can we? Can we do it? Okay, let's let's do it. This is the second favorite question. When we consider the Earth's magnetism, the question says that considering Earth as a short, the Earth as a short bar magnet with its center coinciding coinciding with the center of the Earth, show that angle of deep angle of deep phi is related to magnetic latitude lambda by the relation 10 phi is equals to 210 lambda. We need to prove this, that 10 phi is equals to 210 lambda. 1 phi it's an angle of dip, and lambda, that lambda would be equals to, the magnetic latitude. So how will I do this? Any idea? What magnetic latitude, or how should I define a latitude of any location? Do you have any idea? No? Let me show you first that, and then we will move to the next. This 10 phi is equals to 210 lambda. So first let's understood what latitude is. To define a latitude of any location, what we are supposed to do is that, let's suppose this is Earth and it has been divided in this 4 segments. So this would be the sun, this would be the center. Now let's assume that this is the point P of which latitude is required. So what you are supposed to do is, you are going to make one line from the center of the Earth to that location, and we understood that this is the equators, this is the poles. an angle from the equator to that location in anti-clockwise direction. I repeat, angle from the equator, angle from the equator to that point P in the anti-clockwise direction is the latitude of that place. I hope this is clear. Is it clear? Is it clear? Are you sure? Are you sure? Yes. So now let's have a relation between angle of dip and latitude. So what we are supposed to do is that let's suppose make a rough arrangement such that earth sphere is there. Let's have a look that earth sphere is there, and this has been divided. This is something like this. This is the center of the earth. This is the center of the earth, and at this center a bar magnet is there. At this center bar magnet is there. This is south, this is north, and at this point, at this point, this is point P. Let's suppose I require a latitude. So as I understood that this is north, this is south, this is north, this is south, and I this point P is over here. So we have this situation that let's suppose this is, and let's suppose this angle as a theta, and and this angle as a lambda that we define as for the latitude, and this separation, this distance is r. So from the dipole point of view, this is the north pole, this is the south pole. It is having the positive, north pole is having a positive magnetic strength. Yes, we said it's a plus m. South pole, it is having the negative strength. Yes, minus of m. So we can define a two magnetic field. That let's define the magnetic field, one of them in this direction, and the another in this direction. Yes, let's suppose write this as a b1 and write this as a b2. So if you observe the carefully, this b2 is on the this b2 is, if I consider this as an angle theta, this could be the axial value, that could be the axial value for the magnetic dipole. So we can write like this, that it's a b2 that could be represented as mu naught by 4 pi multiplied by 2m by r cube. We already defined that it can behave as a short bar magnet, so this can be written. And if this is at the axial position, this b1 is considered as the at the equatorial position, and when it is an equatorial position, it could be written as mu naught by 4 pi multiplied by m by r cube. So this is b2, this is b1. Now what I can write is it's a 10 delta, and 10 delta could be written as this is bv by bh, and from this this is equals to minus of b2 to the b1. When I write this I am having the relation that this is equals to 10 delta, that should be is equals to 10 delta, this should be is equals to minus of, but when I write this, it's a mu naught by 4 pi into 2m by r cube. I must add a cos theta at here, and I must add a sin theta at here. Look at this very carefully. This is theta, so when if this is theta, this would be the cos theta component. It is something like this, that if you want to learn it, this is something like this. This is m. So if this is m, this is the m cos theta component. This was m, this is the m cos theta component, and while I say this is m, this is m sin theta component. I hope this is clear. So this is just the 10 delta, that if I take a ratio of, let's say, this as a 1, this as a 2, then this could be written as tan delta is equals to minus of 2 into cot of theta. Let's just replace this theta. We can understand that this theta is equals to 90 plus lambda, and when this theta is 90 plus lambda, let's just replace this is minus of 2 into cot of 90 plus lambda. That can be replaced by 2 tan lambda. This is equals to tan delta. So got it, it's a tan delta, that should be is equals to 2 tan lambda. So did you got this? Did you got this? Even this is the question that have been asked thrice when AIPMTs were there, when AIPMTs were conducted. Is it clear? Is it? So now everything is clear. Everything. Any doubts? No? Great. So let's just wind it up this session over here. This is all about the Earth's magnetism. Yes, we have covered all the theoretical topics as well. But I advise you guys to please revise NCRT of this unit once as well. Why NCRT? Because it might possible that a certain information are there which have NCRT written which I may not covered, so that can be covered. Yes, because this is the completely theoretical aspect of the magnetism. Yes, no logic, no, we cannot say no, everything has not been dependent on the relations and the facts and the formulas and the concepts. Yes, many are things are just the assumptions. So please revise it carefully. Please go through it once or twice. That's why that can deliver to the subconscious minds of ours. Yes, thank you, have a good day, take care, bye bye.